to Catalyst
and hi everyone. Thanks, Brian, for the great introduction to what we're doing broadly in NCPI. I think it's really very helpful. I wanted to dive in, and I think somebody actually had a question in here about this. Right, you know, it's great. Like on that high level, being able to transport data from one group to another is really important. However, I think one of the areas that we still struggle with, I think, in the community a lot of times is actually how do you do that sort of, you know, data element level interoperability, and what does it mean? Like, what does that data actually mean? And so I'm here to talk about the clinical and phenotypic data interoperability using FHIR and the NCPI. So, you know, Brian mentioned there's a lot of different layers of interoperability here. There's a lot of really core items that is important to be able to share data robustly and effectively. And so one of the challenges that we're really going to focus on here is sort of this perceived lack of standards for clinical data exchange. There aren't a lot of ways across the communities that clinical and phenotypic data are really effectively shared right now, specifically in this research environment. I know I've had the experience on both sides of trying to make data available, for instance, over dbGaP. And at the end of the day, a lot of it turns into, well, I guess this is what we can put into the CSV file, and everybody who wants to use it is kind of on their own. And so I think about this problem sort of end to end. I've been involved in every aspect of this now at this point, in this data lifecycle of, I've done some really cool research. I want to be able to share that, make it reproducible for others. How do I do it? Right? I've got to take the data from my local source systems, which in my case, a lot of times was electronic health record data. Got to transform that to make it available for my analysis. But then, you know, what can I share? How do I submit that? You know, how does that go through these platforms to be made available to researchers? And on the other side, as a researcher, how do I access all this data? Can I go and say, hey, I really would like to do a study on type 2 diabetes and get all of those cases and controls that exist, you know, in all these cloud platforms? And I think currently that's something that's still a really big challenge, because it gets down to that level of saying, can I understand that data that's really made available? In the genomic space, right, I think we have really great standards and a lot of consistency about being able to go in and say, hey, I'm looking for variants in this gene. And we all kind of agree on, hey, here's how we talk about every position. Here's how we store that data. These are the file formats. This is how I, as a user, can ask those questions and point to it. With the clinical and phenotypic data, we don't really have those same kind of standards in play. There's that semantic meaning about what is type 2 diabetes, where is that information recorded, you know, how reliable is that assertion that's being made. None of that's captured in the same way that we have in the genomics right now. So I think the goal for FHIR, it's a standard that's been developed and published by Health Level 7, and it's really originally focused a lot on the clinical data interoperability. So how do I, at hospital A, share my data with hospital B? You know, how can I, as an individual, access my clinical data from those EHRs? And so I think in the world at large, it's most commonly found in things like Apple Health Records, where now I can actually, from my phone, I can go log into my patient portal at my hospital, and I can download all of that information. And so I can have a record, you know, if I'm looking, use the diabetes example, I'm tracking my hemoglobin A1Cs over time, I can watch that, and I can integrate that data. And if I am myself am pulling in, you know, maybe I've got a smart scale and I'm tracking that information, all that can come to one place. And so that is using FHIR in the background. And I think that's one really powerful example of how we can interoperate. And so this idea of FHIR, right, it's developed in that sense. It's a free open standard that's been developed in a number of years with a lot of expertise from people who have spent a lot of time working on the clinical data interoperability. The idea is vast healthcare interoperability resources, and you know, some of the high level here, but the real goal here is to be able to say, can I quickly and clearly share this clinical and phenotypic information with others? And I think that there's a lot of driving use cases that we as researchers experience, but also it's pretty clear, I think, in the clinical setting, how it's important to be able to make sure that one's information is portable. So, right, these health records are increasingly digitized, and as we move around, I think it's perhaps, especially in the United States, there's just not ways, there haven't historically been ways to get data from one location to another. It's been a big challenge, especially for people who maybe travel a lot for care or, you know, have complex diseases that require complex management. that's faxing of records around is sort of that classic example that everyone wants to get away from. And so FHIR really is a set of flexible models and best practices that allow use of these APIs and this data. And so Smart on FHIR is one of the coolest things out there too, in that it allows people to integrate for themselves, for their providers, new applications on top of the health records, which in the past used to be really locked down, and there's you get whatever the vendor provides or whatever you can build, but it's pretty restrictive. And so I think one of the big questions we get a lot too is why use this standard for research data? I think one of the big answers is it's actually really robust and flexible, and it allows users to pick their own ontologies, right? And so if I want to talk about something, I may be talking about something in a different way. I'm not using ICD billing codes, right, to do my my data standards in the context of research, but that's okay, right? I can use those other codes that I'm using. If I'm using the human phenotype ontology, something not typically used in a broad clinical care, that's great. You can represent that information. And so I think it's a really powerful tool. It also really allows access into the electronic health record data. In the United States, there's been mandates recently to make data available using FHIR. And I think FHIR itself is a global standard. And we just actually did, as a part of our working group, we did a training with a group called FHIRly out of the Netherlands, and they provided a bunch of tools. And the standards in FHIR are things that if it's 80% of these participating countries really need these resources or need these features that'll be incorporated. So I think it also provides a lot of power in that regard. So yeah, there is a structure that does provide the structure so you can really use truly technical interoperable exchange, but also does provide that flexibility. And so I think it covers most of what people are representing in these common data models or in their data submissions right now. And so the key building block is the FHIR resources. And so those basically, one can conceptualize them. This maybe is a bit reductive, but sort of as these complex JSON objects is one way that they're often actually represented, actually manifested. But they're complex objects that have a model behind them. There's tons of different types of resources. And so it really allows you to discretely add or move those bits of information. They have well-defined meanings. Their structure there. They're also extensible as necessary, but it really allows you to clearly specify both the data and the semantics. And there's a lot of great documentation, which I think is also what's really helpful. I mean, if you go check out hl7.org/FHIR and see what's there. We're not going to get into it, the details here, but as you see here, there's a lot of different resources, and there's very clear definitions about what is backwards compatible, what might change over time. How confident is the group in the way the data is being modeled. And so it's definitely something in development, but I think there's also room, and the working groups have been excited and engaged in this, for us to participate as researchers sort of in making our needs known and going there. So right now, a lot of what we have, and I mentioned this before, is these tabular data files. And that's, for instance, what's in dbGaP. That's what researchers use themselves, right? If I need to do a logistic regression analysis, like I need that table that has my outcomes and my predictors in there to go with my genomics. And so the idea is that one can also map this existing data, providing that semantic information in there. So I know this isn't just a true false field that maybe there's a description in some PDF someplace, but I have that structured concept that says, no, this true false is diabetes status. So we can map that information then into FHIR, map those values to terminologies as necessary. And then we can really use that data and share it, and it's really clear to anyone who picks it up. There's obviously a lot of complexity that adds, right, from that CSV file, but at the same time, like, that's a manageable complexity, and with the right tool support, and that's one of the big goals that we have. It's kind of Brian was describing before. It becomes accessible. It's not just the complexity of, wow, every phenotype for every individual, every representation possible of data that's out there. We can actually say, hey, here's at least a consistent representation. And here's how you can get access to that data. Here's how you can ask those right questions. So the specifications, right? One example here, this is from the Kids First Data Resource Center with the POPs caring for kids with COVID data. They're actually able to, they're building these index libraries, like these modules as necessary to incorporate data from existing sources. So can do the mapping from the data coming from these clinical trials, these studies, and actually transform that into this FHIR JSON to be loaded into the FHIR service. And so FHIR, once again, is this interoperable framework that we're aiming for. There's idea of this flexibility sort of this data modeling framework, so you can make sure that whatever data you have and is important to you, you can capture. But there's also a lot of the base data model that's highly structured, as well as the API. So there's a RESTful API that comes along with it that provides a lot of utility. And so once again, if we can go from this place where we have PDF data dictionaries with CSV files into a place where we have sort of these self-annotated resources and a structured API to use them, all of a sudden we can make some of those dreams real. And I think some of those ideas are this idea of a platform and a portal, right? I can actually now go potentially, to Brian's comment earlier about search, I can go and say, hey, let me ask a few of these services out here, a few of these platforms. Hey, do you have any data that looks like this? And so we can do that, and you can actually display and model and some of these pieces to users. And so it also allows for some of the structured bulk export between platforms. Things like FHIR can go inside those PFBs that were mentioned before, right? Because it is, once again, it is these complex objects that can be modeled in that way with clear data dictionaries. There's also the idea of computational researchers, right? You can do these API-based data pulls, and some perhaps manage that complexity, being able to go and say, hey, give me all the blood pressures for people is a query that one can make against the FHIR APIs. And so that is a really powerful tool, I think, that can be challenging sometimes as is. And then, it's also possible to do these rapid analytics and apps. And actually, this FHIR browser up here, the Shiny app is something that I was able to put together. I hadn't used REST APIs really before this. And with a little bit of time, was actually able to pull together a Shiny app that accesses this data, that does some of this parsing. And it was really exciting to see how quickly one could iterate with the standard data as it actually gets modeled robustly in FHIR. So one of these ideas, right, we're working on this data modeling framework. I mentioned some of those maturity levels as we're continuing to find this. So one of the other great things about FHIR is the documentation pieces, and that's often managed in this implementation guide. So there are a lot of ways, as you can imagine, sometimes in this flexible framework to model some of these decisions. And those standards and those decisions that are being made, there's actually a whole framework for representing them and making them available, making it really clear, hey, what are the best practices in our particular environment for modeling the data this way? And I think one of them is, for example, you talked about human phenotype ontology terms before, right? There are a few ways to say something is present or absent. And so what are the best practices that you want to do? And so we as a community then can define and say, hey, if you want these really fancy tools that we're building, if you model it like this, everything will just work. You can plug it in. You as a new user can bring in your data, and if you model like this, it'll work with all the tools. And so I think that's something that's very exciting. And so we've been working on this implementation guide. There are a lot out there for even some of the basic pieces of, the US Core Guide for healthcare there, and even this bulk data tool, right? There's a lot of existing implementation guides, but we're actually building one as well to really better represent the types of things that we're working on, to add some features to the research study and research subject, be able to make it really clear when something is a DERS document reference, right? So we can incorporate those pieces that Brian was talking about before using the DERS standard. We actually pull that out and make that available as well and say, hey, you can go use this URI that we're providing with DERS and get the data you're looking for. And so I need to, I only have a few minutes left. So I'm going to slide through some of these slides here. One example here, right, this idea that we can talk about in this clinical trial sort of setting, we can talk about remdesivir, we can look at that code and coding now that we can build into this medication entry. And so we're actually able to, to go from this thing where, well, the only reason why you knew it was remdesivir is because it said it in the file name, into a, really structured representation using, these standards for medication representation. And so that's, really exciting. And I think that's a really powerful tool. And the same thing here as well, like these pain scale assessments, right? We can choose the right controlled vocabularies, this idea of a score. And so now it's once again really clear that this is this, pain severity total score, and not, some random number or just some random column in a data set. And so we're working on this as well to try and to help guide people towards, hey, what are useful vocabularies on ontologies? And there's a lot of work out there, with, like, for instance, Melissa Handel's group and looking at human phenotype ontology. So we've got some available on GitHub. There's a place for conversation there if you're interested in engaging. The NCPI GitHub is out and available. And I want to say thank you, of course, to the NIH for sponsoring this across all of these different projects. And of course, those FHIR working group members who have been contributing, especially sort of materially, to the development of these resources. And so I'm really excited about FHIR. I think it provides a real framework for us to share data robustly across all these platforms, all these different initiatives to really help enable us to provide a lot of the cool tools that we have for genomics about QC and other work. If we get to that same kind of baseline with clear standards that have been widely adopted, I think we can really provide more of those tools, like the Odyssey community does for OMOB. So thanks. And I guess if any questions.
Thank you so much, Robert. This was a fantastic talk and exciting work. There's one question that we have a little time. So FHIR should be enabled to query across different types of data before you actually get access to the data, correct? So are you using FHIR for search?
Yeah, that's a really great question. And so we've talked about this a lot. I think one of the big challenges with all of this is that security compliance. How do we make sure that we are respecting the consents of those participants? How do we make the data as available as possible? And so I'm not sure we're at a final solution on this, specifically because what you're allowed to query exactly out of the FHIR services. I think one of the goals at a minimum, right, is to be able to represent summaries of that data, which can also, turns out, be represented in FHIR. So the same idea one might have on dbGaP, where you can go through and look at the data dictionaries, you can look at those variable reports. I think that's something that everybody's really interested in making available. As far as the question of what are you allowed to query, there's a lot of challenges about inference into data sets, right? If I can say, hey, is there anybody who has diabetes and has, breast cancer, that might actually allow you to sort of have some of these attacks, privacy attacks, essentially, on the data set. So it's unclear. I think we'll probably be starting with another structured set of reports. But once again, they'll be accessible. They'll be linked to these vocabularies and ontologies. And so I think that will be still helpful. Once one does have access, right, the search is a little different. But I think we are looking towards ways to be able to ask questions like, how many people in this data set I don't have access to? Can you tell me how many of them have diabetes? I think that's something that can be accommodated.